Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everyone, dear colleagues, welcome to our third international conference on water problems in Mediterranean countries and our sixth international conference on natural resources and sustainable environmental management. Today we are in Wpmc session 4. We have a couple of researchers who are willing to share their research and their findings with us, and each researcher will have 15 minutes of time allocation. Our first researcher is Dr. Ersi Kalfoğlu.
Hello, everyone. I am very proud of being part of this conference, and I'm very happy to be able to talk to you. Well, I will talk about can I have my device? Okay, thank you so much. I'm going to talk about beta-lactam containing antibiotics in wastewater, and I'll try to talk about their effect in ecosystem in general. This is a work that we have started with a colleague of mine who is called Elif Şahin. This is part of a bigger project, as I will tell you later in the slides. Okay, so what is beta-lactam containing antibiotics? Those are antibiotics that they have this chemical structure. This is the first structure that was found as an antibiotic by Fleming. And then between 1940s and 1970s, a great development related to new semi-synthetic derivatives and molecules on this basic molecule that you have seen. The places where the new antibiotics and the derivatives are shown by the two red arrows to you. Okay, what are they doing? What is their mechanism of action of those antibiotics? They actually inhibit the cell wall biosynthesis of pathogenic bacteria. Actually, this is what Fleming realized. Well, unfortunately, bacteria are able to tolerate or resist this action of antibiotics. And it is that the laboratories firstly found that they have this kind of a resistance. Then the clinical medicine realized that this is a real problem. In fact, this is not new. We have beta-lactamase enzyme that was found million years ago. Therefore, actually, the bacteria had the way of trying to protect themselves. And long before their use in clinical medicine, they knew how to work with antibiotics. Well, today, this case is one of the most pressing public health crisis, the evolution of microbial pathogens that can resist antibiotics treatments. The European Center for Disease Prevention and Control says that each year 25,000 people in Europe die directly because of these drug-resistant bacterial infections. And the British government, in a work that they have done, they suggest that a worldwide mortality is around 500,000 people. Therefore, this is the greatest problem. But yet we are continuously producing and continuously increase the use of antibiotics all over the world. Actually, antibiotics are used in medicine, but also in other commercial activities, which is, again, problematic. Somebody can say that, okay, the level of antibiotic compounds in the environment is very low. The levels are very low. So the risks should be negligible for human beings. The answer is no, this is not the case, because they are present in the environment in low concentrations, but they can accumulate in human populations, in human beings. And this is going to be actually a long-term exposure to drinking water, to food, and all these may have different consequences. Even in chlorinated drinking water, we sometimes do have antibiotics that can be problematic. You probably know that we also have antibiotics in goods such as soap, clothing. We can find it in stream rivers all around the world. It has been found in breast milk of human beings. And you can understand that this is a very serious problem all over the world. Well, Europe actually started a real fight with this kind of pollution and to overcome this crisis that is really problematic. And they have a great deal of investigation that is going on, and they have research and a policy, and they call this initiative EU One Health Action Plan. And they started that in 2017. And they want, actually, what they want is to make Europe the best practice region all over the world, to develop and innovate on the area and actually shape a global agenda. Therefore, Europe is the main power that is dealing with this problem. Now, the reason that I wanted to talk about this phenomenon is to tell you things about Istanbul, which is a very populated, the greatest city all over the world, but it is a very highly populated city where almost 20 millions of inhabitants are living in. As you can understand, the pollution in general, the water pollution, and specifically the antibiotic pollution in Istanbul is high. Now, we don't have scientific data about antibiotic pollution in water related to Istanbul. There are several works that have been done, even for drugs of abuse, but we do not have specific data about the antibiotic use in Istanbul. ENÇESU University, the university where I teach in, we decided to start and collect scientific data related to uncontrolled discharge of beta-lactam containing antibiotics in wastewater. The city of Istanbul, as you all know, is situated both in Asia and in Europe, and we have the magnificent Bosphorus separating the two continents, but this is a water canal, as you can understand. Anyway, beta-lactam containing drugs constitute the 66.7% of the total antibiotic use in Istanbul. Now, 34.2% are penicillins, and 32.5% are the other penicillin or beta-lactam containing products, antibiotics. Now, what happens in Istanbul? We have 55 wastewater treatment plants in the European side in Istanbul and 34 in the Asian side of Istanbul. And they're treating more than 6 million cubic meters wastewater daily. One should think that this is okay. This is quite a big number. However, what we have here as 6 million is actually the preliminary treatment of wastewater, where we have physical methods that are being used. But certainly for the antibiotics, we have to have biological treatment, and not even that is not enough. We need to have higher biological treatment to be able to work with antibiotics or treat water for antibiotics. Now, the high biological treatment capacity in Istanbul in cubic meters per day in the European side is about more than 1 million. In Asian side, 800,000, which makes a total of more than 2 million. However, this is not enough. Certainly, when we are talking about this kind of a pollution, we have to talk about most probably hospital areas, which probably are the places, the centers that will discharge more antibiotics than expected. However, our point and our interest is in more than that, more than hospitals and medical centers. The most serious problem arises because of animal breeding in Istanbul. There are quite a lot of animal breeding centers in Istanbul. And why this is very important? Because we don't have any regulation, any collection of wastes, of animal wastes in the city. Therefore, there's no control about that. And we do not know exactly what is the mixing capacity of wastes, and specifically antibiotic wastes, in the soil, which then, as you can all imagine, everything will go regularly in everything else that we're actually using. Let me show you some examples of animal breeding in Istanbul, and you can see that we have a continuous increase in Istanbul related to animal breeding. It's okay, and as you can see in Istanbul, we do have lots of centers that we have this kind of cattle breeding or whatever facilities. This is a real and very serious problem related to antibiotic pollution all over environment, all over the environment, and certainly related to wastewater. We certainly cannot say no antibiotics, but at least, let's say, some antibiotics whenever it is required and whenever it's necessary. And hopefully, we expect sometime to be able to detect the amount of antibiotics, or to control the possibility of discharge of this kind of the very, very serious problem that we encounter in our city specifically, in our country in general. So the amounts of antibiotics released accumulate in the environment this way or the other, or one way or the other, and we have lots of unexpected potentials of real problems that can be created for human beings, for animals, for the nature in general. This is what I wanted to talk about today, and I would like to finish my presentation here, because I guess it is 15 minutes the time that I was allowed to speak. But I hope that soon I will be able to give you specific information about antibiotic discharge in the city of Istanbul, and to be able to work, control, or talk about this real important event. Thank you.
Thank you very much, Professor. Thank you very much for your valuable insights and sharing every every comment that you have in your mind and everything. Thank you very much for your contribution, and thank you for your attendance. Thank you. Next presentation will be from Dr. Amos Kayflor Zayas.
Good afternoon to all. Let me first start by extending my sincere gratitude to the organizing committee of this conference for affording me the opportunity to share my research with you all. Please upload my slides. Okay, thank you. So my topic is evaporation estimation of the Chicoid reservoir using meteorological data. Evaporation basically involves the transformation of liquids to gas phase, normally below boiling points, and it forms a very essential part of the global or regional water cycle, and has a direct link with issues such as global warming, as previous studies have found an increase in the Earth temperature highly affects evaporation. Also, evapotranspiration is basically a conglomeration of both evaporation and transpiration, and also have serious influences on water sources like soils, canopies, and other water bodies, of which has its own environmental impact as it relates to water management in the usage of water in areas such as irrigation and domestic use and so forth. The objectives of these studies includes the estimation of evaporation at the Getchikoy Reservoir in Turkish Republic of Northern Cyprus. It also aimed at assessing the relationship between actual and potential evaporation, and also to identify climatic seasonal patterns and anomalies as well. The methodology includes data collection, analysis, and so forth. Firstly, the Reservoir is located in the Turkish Republic of Northern Cyprus, which is a major water body in the nation as it provides water for both irrigation, industry, and domestic use. The Geshikor Reservoir is located within the Caribbean region and is majorly input of water comes from two major sources: the Aleppo Dam in Turkey, which received we sent water to the Geshikwa Dam through an 85-kilometer underwater pipeline, and also through the climatic conditions such as rainfall or precipitation. The study used two major data sets, which is the chirps and that of models to estimate evaporation at the Geshikor Reservoir. CHIPS is a climatic data set that can be found on sites such as applications such as Climate Engine, and MODIS is also an instrument with 500, 250, 1,000 viewing lens that travels the Earth every 1 to 2 days and is found on satellites such as the Terra satellites and that of the Aqua satellites. The findings of the study, firstly, the findings of the study shows that the water sources in the Turkish Republic of Northern Cyprus includes precipitation, dams, ponds, groundwater desalination, and waste management processes. And the Cyprus Republic of Northern Cyprus, Turkish Republic of Northern Cyprus, sorry, has a serious water deficit, which extends as far back as the 1960s. And as such, studies that involves water management is highly necessary within the region or the nation at large. As per the study conductor finds that precipitation within the region for which the Geshikoi reservoir is located has some variation with regards to the rainfall pattern as seen in the slides. The monthly variation shows erratic pattern observed, which December consistently have the highest rainfall, and the winter month also is wealthier than the other months. We show a seasonal variation, and also there's an annual slight increase within the precipitation with regards to 435 millimeter in potential 435 millimeter of rainfall in 2020, 442.43 millimeter in 2021, and 436 millimeter in 2022. This implication for the Geshikor Reservoir includes seasonal irregularities, which emphasize hydrological regime for adaptive water management, and also provides prediction on the water deficit and precipitation signals potential water deficiency, which is crucial for reservoir strategies. And long-term trends may arise in 2021, followed by a drop in 2022, which highlights the importance of considering long-term trends and calls for action, which includes the urgent need for detailed investigation into water supply for sustainable resource management. Also, the potential evaporation as per the MODIS data shows that the monthly nature in millimeter covering January 2020 to December 2022, also as indicated in the rainfall pattern, shows high potential evaporation during the summer months, and which can be attributed to the increase in the hotness of the region during the summer months, and that of uh, the decrease in temperature during the winter months and fall periods, which shows a decrease in the potential evapotranspiration as seen in the slide. Also, the yearly variation shows a highest total annual potential evaporation in 2021, which shows a total of 2,066.25 millimeter for the potential evaporation in the year 2021, and the lowest was in 2022, which shows a total of 1,858.09 millimeter for the potential evapotranspiration. It's noted in other studies that the barrier creation, it says the barrier creation introduces composed of humid air above and that of above the water surface to reduce evapotranspiration. The reservoir inflows is basically as per the get record as stated before, is basically as a result of precipitation and that of water flow from the Alakbur Dam in Turkey, and also the dam reservoir shows three basic outflows: evaporation, outflow to domestic usage of water or municipality use, also irrigation and that of industry, and also there may be some interaction between the reservoir and that of the groundwater as well. The major finding of this study, which aim at estimating the evaporation of the Geshikwa Dam, it shows that the net evaporation of monthly and total evaporation for 2020 to 2022, the calculation of the monthly and that of the yearly evaporation was done using the formula potential evaporation times 0.8 subtracted from the of which precipitation is subtracted from the total amount gathered from the multiplication of the potential evaporation by the actual evaporation as per a study conducted by the USGS on water evaporation in the South Florida wetland. The findings of this study shows that the net evaporation exhibits a clear seasonal trend as well throughout the 3 years, and the value indicates a high dependence on environmental water, while negative value represent period of moisture and surplus analysis. According to 2021, the highest evaporation rate was 1,210.57 millimeter of the Geshikwa Reservoir, and the lowest was in 2022, which shows a total of 1,049.652 millimeter. This shows that understanding these patterns can aid in the balancing of water availability within the Gesicor reservoir, and also it do signal or help decision making as identification of months with significant net evaporation or condensation can assist in making decision as it relates to agriculture or water supply and ecosystem uh, operations. To conclude, the 3-year evaluation of meteorological data and models for seasonal and anomaly evaporation transpiration was detected. And for planning and consideration, it highlights the importance of considering varying rainfall level and high air temperature when planning for water management. Also, the significance of this study with regards to seasonal and anomaly decisions, detection rather, utilizing meteorological data and models allows for the identification of seasonal patterns and anomalies in evapotranspiration. And also with regards to weather variability, the study acknowledges that trends helps in coping with variation of rainfall and high air temperature, which also is crucial for water management strategies. In application, understanding net calculated evaporation aids in planning for the loss of precipitation due to evapotranspiration, contributing to effective water resource planning. The study emphasizes the importance of utilizing meteorological data and models for the detection of both seasonal anomaly with regards to evapotranspiration in the Getchikoy reservoir. Lastly, the study recommend that in water management, seasonal changes in water loss due to evaporation for effective water management should be observed. Create a flexible water management strategy with a focus on continuous weather monitoring, especially during unusual events such as high potential evapotranspiration period. Also conduct an extensive long-term research to understand trends related to climate change and its impact on the areas of water supply. And lastly, leverage evaporation data for improved irrigation decision using modern measurement tool for precision. Thank you for listening, and I submit my presentation. Thank you.
Thank you very much, Dr. Ramos. Thank you very much for your presentation. Thank you for attending to our conference. Next is our next presentation is Dr. Salih Saner.
Hello, everybody. This presentation is coming to you from North Cyprus. Cyprus is an island. How it was formed is a question always. For this study, we did some literature survey and investigated breakup of Pangaea continent and breakup of northern Gondwana edges. Then we did some field studies, observations at the field, and whatever we are thinking, we embedded Cyprus evolution processes into the system. Cyprus is third largest island in the Mediterranean Sea. Its surface is 9,250 square kilometers. East-west length is about 200 kilometers. North-south width is 50 kilometers. Troodos Mountains and Beşparmak Mountains. Troodos Mountain is 1,952, the highest point, and Beşparmak Mountains in the north, parallel to the coast, is 1,024 meters in height. And between two mountain ranges, we have Mesaria Plain, a depression area. It's a plain area between two mountain ranges. And also, let me mention also, in Cyprus we have two states, Turkish Republic of Northern Cyprus in the north and Greek administration in the south. When I was small in the school, they taught us Cyprus submerged undersea 3 times. And of course, as a child, elementary school, even high school, even today maybe they are teaching in the same way, submerged 3 times. What is the meaning of it? Is it a fish, like diving into the water? Of course not. With the developing science, especially after 1960s, with new concepts, new theories, geology made a great improvement, and plate tectonics came out. Of course, these are happening because oil companies are looking for more oil, and without geology, you cannot go explore and exploit oil. So geology improved very much. First of all, before going to deep into the topic, I have to tell you that the Earth crust is not continuous. Like the skull, it has discontinuities. For example, in this map, here is a discontinuity. And here is Africa, here is South America. And all this together is a plate, and on this side, this is another plate. How they are occurring, how they are moving is of interest. And the main thing that I want to tell you here is rocks in the oceans, bottom of the oceans, and the rocks on the lands are different. We are calling this one basaltic type, oceanic crust, and this one is a continental crust. In a cross section, in the continents, we have continental crust, which is about 70 kilometers thick, and oceanic crust is about 10 kilometers in thickness. Basaltic, granitic. What happens? So this one is a granitic continental crust and oceanic crust. This is the map 225 million years ago. There was single continent, Pangaea continent, and Panthalessa Sea, 225 million years. There is a bay here, big ocean is coming into the land. It is called Tethys Sea. And our today called North America, Europe, South America, Gondwana, India, Australia, Antarctica, all there were single continent. In geological time, so this single continent, 200 million years ago, started getting broken, and 160 million years ago, started getting separated, more separation, gradually, they are getting away from each other, 80 million years, 40 million years, And today, where is Cyprus? I can recognize many countries here where they are. For example, Italy is here. India was somewhere here. Saudi Arabia is still here. But where is Cyprus? Small island. Where is it? So we are looking at the area, our area. Here is Cyprus. There is a big steer zone where Africa plate is subducting beneath the Torrid area of Turkey. Dead Sea and Arabian platform. This is the area. Cyprus is here. But where was it before? When we look at the geological map, simplified geology map of this Cyprus, we are seeing Beşparmak, Five-Finger Mountain Zone to the north, Troodos Mountain in the middle and south, and basins in between. So this is main three elements. Here is also something like Beşparmak. I will talk about them. And when we compare the sediments in Cyprus, sedimentary rocks, in Mesaria area and Girna area, those Beşparmak mountain has lots of different rock types which are not available in the Mesaria and south in Troodos. So too much difference. Mainly Beşparmak area lithologies, rocks are scrambled, mixed up. We call it because of the tectonic movements. It has fractures, deformations. Therefore, we call it the word is coming from French, mélange or accretionary prism material. And this material here in the Mesaria is material sitting on the Troodos mountains rock. We go back again. The Pangaea was broken, you saw the map. Now I am coming to another set of maps. This is Africa, Gondwana continent, and Eurasia continent. Between these two, this area here, this area was the bay that I show you in the map, Tethys Sea. Tethys Sea is coming like this. And at the edge of the Africa, some small microcontinents started to break off from Africa. So, and new sea started opening. So we call this one Paleotethys. Gradually, this material here going to push up to the north, and this one is going to get closed, and this one is opening. This one Neotethys, and this is Paleotethys. Neotethys is the Tethys, Mediterranean Sea today, opening. And I can start thinking, looking at the rock material in the Cyprus, of course, when I say occurrence of Cyprus, two issues. One is occurrence of the rocks, rock types. What is the date? What is the age of the rock? And the second thing is, when did all these things rise up to the water level, above water level? So opening started 119 million years ago. Oceanic crust started getting formed, and these are pushed to the north to close the Paleotethys area. And these are the blocks, microcontinents, Kırşehir, Sakarya, Menderes, East Torres, Antalya blocks are spread like this. Altogether, they are pushed to the north. And gradually, Paleotethys is closing, Neotethys is opening 65 million years ago. I said I got many things from literature, and I am mounting our opinion about the occurrence of the Cyprus, evolution of the Cyprus island. So here is still we have oceanic crust. There is no Cyprus. Cyprus is not in the map. Let's go one more. In Eocene time, 42 millions. You see Turkey is, those blocks are coming together and forming Turkey. These are continental, broken off pieces, continents, and in between them, we have melange material or accretionary prism materials between them. Another one is this area, Cyprus area. On the map, we are seeing this fault started to push, Africa started to push northward along this stir line. And when it is pushing, this was oceanic crust pushing, the material started to getting broken off here, many fractures, and forming accretionary prism in the area. Accretionary prism is when you push rock by another one, you are going to get lots of fractures and implication of the blocks. Those broken blocks are going to get implicated, like the bricks of the house, top of the house. And this area started getting implicated, blocks pushed southward, and this one is pushing northward. It is Eocene, 42 million years ago. Still there is no Cyprus. 42 million years ago, still there is no Cyprus. When we come to 15, 20 million years, we are having Troodos Mountain start coming up to the sea level. And since it is coming up to sea level, we have some coral groves, reefs occurring also around the Troodos Mountain. In North Cyprus, if you go to Limniti or in the area, many places, you can see these patches of coral reef remnants there. Benchmark is little bit late coming to the surface of the sea, that level, and we are having two islands, Benchmark Island and Troodos Island, two islands, and small islands of coral reefs. Coral reefs are formed at shallow water, usually cannot be living in deep waters. And later on, after this stage, sea started getting dried. Entire Mediterranean area is drying. And Cyprus is here. There are different phases of drying up. Some rocks, of course, when you dry water, what you get a salt deposit. When I say salt, it is not only salt that we are having in our kitchen. That one is also available, but there are different sulfate minerals, magnesium minerals, different potassium minerals, accumulated. In some areas, it is getting sabkha-like deposition. Sabkha is a salt flat, like if you've been to United Arab Emirates, the water is coming on the land, it is sabkha area. And there are deeper areas that we are having salt lakes. So salt deposition here, salt deposition here. Therefore, all the salt covering the area, they are not the same type. There are differences, but entire Mediterranean was drying up. And Cyprus was also dried up. Then sea started covering the area again in Messinian So no, in Messinian still we are having this subcast, the drying up time, and following this one, sea started to rising up again. And in Miocene, Pliocene period, 2 to 5 million years ago, there was a sea again, Beşparmak and Troodos. So this is second time that we are having two islands, but very shallow sea, which gradually, island is continuously moving up. And even today, 1,000 years, 2 millimeters, it is going up. So again, it is coming as land. And this is the cross section that I am getting today. I have Turkey, Torit block, and here Troodos, Mesaria depression area, Beşparmak area, and some young sediments covering the Mesaria and covering the sea between Turkey and Cyprus. If you look at this map, this is continental crust here, and these are the material implicated. You see, they are all broken and pushed down because the Africa continent is subducting beneath the material and pushing, and this material is getting upthrusted and implicated in the area. Therefore, we are talking about today earthquakes mainly happening here. This is the main subduction zone. Benioff zone is this one. But the measured earthquake depths, epicenters, are giving very shallow depths, 5 kilometer depth. Most probably, these are the faults moving. So we are lucky. If the crust is getting broken here, it's going to be a strong earthquake, and this is getting smaller, discharging the energy. And this is Troodos, again, Beşparmak. All together, they are accretionary prism. The area is on accretionary prism, implicated slices. And let's say Cyprus did not submerge underwater. It is tertiary basin is a four-dip basin on the accretionary prism in front of Cyprus Arc. Island is an uplift of two tectonic slices, both belonging to the accretionary prism, Troodos and Beşparmak, two slices. And we are calling the rock type here, Troodos rock type is ophiolite. It belongs to the outcrop of the oceanic crust. So Troodos is the material occurred at the bottom of the ocean in Cretaceous and uplifted. And Beşparmak is a melange area. Melange in French means a mixture of different things. Between two slices, we have Messinian evaporated outcrops taking place. And this is all what I wanted to tell you today. Thank you very much.
Thank you very much, Dr. Salih Saner, for your presentation on the evolution, geotectonic evolution of the island of Cyprus. Our next presentation will be from Professor Dr. Özge Özden Füller.
Hello, everyone. I am just going to share my screen. Hello, can you hear me?
Yes, hocam. Yes, hocam, we can hear you. If you share your screen, if you share your presentation, everything will be perfect. Can you try to share your screen? Under there is a button as present, and after that there is a section as share screen. Yes.
Hello, can you see my screen?
Hocam, we can see your screen. Previously, it was all right. Yes. Right now, whenever you put whatever you put onto the screen, we will see it. Right now, we can see your
Okay.
presentation.
Okay, today I will give you presentation on importance of coastal zone management, which we carried out in Tatlısu region. It's a case study in Tatlısu, Cyprus. And the outline of this presentation will be introduction of our research, study area, methodology, results, and conclusion. As we all know, the Mediterranean Sea is the largest semi-enclosed sea in the whole Mediterranean region. The region has a wealth of biological diversity, including coastal plains and wetlands, as well as attractive landscapes, favorable environmental conditions, and rich cultural heritage. And it's a very popular travel destination worldwide. And Cyprus Island, with its distinctive natural ecosystems, it is situated in the eastern Mediterranean Sea. And our research region was Tatlısu region. Tatlısu is one of the most important coastal area on Cyprus Island, and it has received the legal protection as SEPA, Special Protected Area, with Parliament decision. And it's a special area for conservation of nature. This site has primarily been selected because of its importance and as both nationally and internationally important sea turtle nesting area. However, the Tatlısu region has also experienced losses and in some coastal habitats due to the touristic investments such as accommodation, restaurants, cafes, and camping areas. In this paper, habitat loss, habitat fragmentation, and degradation between the years of 2008 to 2023, using GIS and remote sensing methods were used in order to assess the habitat loss or degradation within the area. I put you some photos and a map showing Tatlısu SEPA on Cyprus Island. And it is close to Kyrenia region. Actually, it's between Kyrenia and Karpas regions. And it has a really beautiful coastal zone. Okay, this map is showing part of the Tatlısu SEPA existing habitat types. These habitat types are under EU legislation. Habitats. For example, we do have 2110 shifting dunes along the coastal zone, and we have many other EU criteria, important habitats within this region. Other part of tablosu showing again existing EU habitat types. And with the methodology, we check the polygons, vegetation polygons, which we taken the polygons from our forestry department. And each polygon, we did surveys and identify the vegetations and also habitat deterioration observed. So when we put our results into GIS and the map system, these maps are showing see the red color patches are the development areas, and in these areas we had unfortunately dramatic habitat fragmentations and dramatic habitat loss. Percent in the past 15 years. Construction and particularly an inappropriate mass building developments and the degradation of habitats. So when we look at our surveys and our GIS maps, we found out that 2110 embryonic shifting dunes, 2260 Cistolaventulata dune sclerophyllus shrubs, 5210 arborescent mattoral with juniperus, 5420 Sarcopterygium spinopyrganas, and 9320 Olea and Serotonia forest. All these habitats, which are really important according to the EU Habitats Directive legislation, we had a very important habitat damage and habitat loss due to building developments. So when we look at this map, it is showing the most important turtle nesting beaches in the region. It's called Zambak. It has a village, Zambak Holiday Village there, Mersinlik Beach, Kantara Beach, and Kaplıca Beach. These are important nesting sites for Caretta caretta and Midas. And this map is showing us the number of nests, turtle nests along these beaches. As you can see, blue color is Zambak, gray color is Kantara, and Kaplıca is the yellow one. It is mostly dense touristic developments happening in these areas. Only one that no developments happening is at Mersinlik, and Mersinlik Beach had the highest number of nests, as you can see. So the tourism affects negatively the number of nests of the turtles. So when we come to the conclusion, unfortunately, Mediterranean region countries are losing many special natural habitats, especially due to tourism and urbanization investments. And due to its special location, the island of Cyprus has an extraordinary variety of dune and coastal habitats. According to the EU legislation, many sensitive habitats on the island of Cyprus must be protected. Conservation of such habitats is not only important for sea turtles, at the same time, Migratory birds also use these habitats, and many endemic plant species live in the region. And this research has shown that the Tatlussu Special Environmental Protection Area, which is extremely important in nature conservation biology, some habitat types have been destroyed due to structuring problems, and some have already disappeared. However, it should be inevitable for the countries in the Mediterranean region to protect such important natural habitats, to care for a sustainable future, and to take the necessary administrative measurements. Thank you for listening my presentation. If you have any questions, very happy to reply.
Thank you very much, Dr. Özge Özden Füller. Any questions will be directed to your email. Thank you very much for your presentation. And thank you for attending to our conference. Our next presenter is Dr. Firdevs Emine Sezer.
Hello everyone, my name is Firdevs Emine Sezer. I am a PhD student at Istanbul Technical University. I want to present my colleagues. I prepared this study with Irmak Öztürk, Zeynep Çetin, Associate Professor Burçin Atılgan Türkmen, Professor Dr. Fatoş Germeli Babuna, and Associate Professor Murat Çakan. My topic is Environmental Life Cycle Assessment of a Sustainable Building. I have a standard content list, and I present the advantages of timber. The construction sector is responsible for the most significant share of greenhouse gas emissions, with 37% of global emissions. The sector consumes 33% of resources and 20% of fresh water, and causes 40% of solid waste. The construction impacts of buildings account for 10%, and operational impacts of buildings account for 17% of emissions. Emissions reduction up to 31% rate can be achieved through circular building materials and more efficient construction implementations. One of the solutions is using renewable and nature-based materials such as timber instead of concrete and steel, which have high emission intensity. The advantages of timber is natural and renewable. Timber production causes much less energy consumption and less emissions compared to concrete and steel. Biogenic carbon storage during its service life is obtained from timber, and timber can be incinerated for generating energy at the end of life. Life cycle assessment method is used in this study, and life cycle assessment consists of 4 iterative stages. These are goal and scope, life cycle inventory analysis, life cycle impact assessment, and interpretation. At the first stage, the goal and scope are defined. At the inventory analysis step, raw materials, energy, and all other inputs and outputs, that's emissions and waste, are determined. At the impact assessment stage, the potential environmental impacts at the collected inventories are evaluated. At the final stage, environmental impacts results are examined and interpreted. The aim of the study estimate the life cycle environmental impacts of a sustainable building that designed by Deeply High team for Solar Decathlon Europe 22 competition. Used building materials have high circularity potential and designed to use as few materials as possible. The claddings, plasters, and stick panels do not need additional painting or coating. All wall and ceiling construction in the vertical extension follows the same dimensions and concepts to keep the variety of materials low. The pictures at the left show the building, designed building, and the right picture show the building life cycle assessment phase. There are 5 phase manufacturing, construction, usage, removal, and benefits and liabilities outside the system limits. And in this study, system boundaries consist sourcing of new materials, transportation, production in the manufacturing phase, and for usage phase, replacement and energy consumption during use is included, and for removal phase, waste processing and disposal are included in this study. For inventory analysis, the material is obtained for the building structure, concrete, timber, and the other building materials. The energy usage from the grid and electricity generation from the photovoltaic modules are entered in the tool, and also the 50% of the electricity is generated from the photovoltaic modules, and the building is detached house, and net living area is 84 square meter, and prefabricated concrete is used for foundation. The building has 2 floors and 3 rooms, and insulation is straw is used, and windows and the doors and all structure material is timber, and the lifetime is assumed as 50 years. Waste disposal scenarios are used for this study. At the table is seen, and CCALC tool is used for impact assessment. The tool developed by the University of Manchester and has 3 databases. It's CCALC database, eco-event database, and user database. User database is developed for the external value entry, and we can enter the value from the literature values. And in impact assessment, the evaluated impact categories are global warming potential, acidification potential, eutrophication potential, ozone layer potential, depletion potential, photochemical smoke potential, and human toxicity potential, and also primary energy demand. And at the results, the graphic shows carbon footprint of building phases, and the total carbon footprint is 30,000 kilogram carbon dioxide equivalent for a whole building, and the usage phase is 28,000 kilogram carbon dioxide, and the manufacturing phase is 2,800, and removal phase is minus 800 kilogram carbon dioxide equivalent per kilogram carbon dioxide equivalent, and carbon footprint values are converted per floor area for the comparing other studies, and the total carbon footprint per square meter is 356 kilogram carbon dioxide equivalent. Life cycle phase breakdown are shown at the graphic, and the usage phase contributes with 93% of the impact, and manufacturing phase is responsible for 9%, and removal phase is reduced by 2.6% of the environmental impacts. And material breakdown for GVP are shown at the graph, and the biggest contribution is from photovoltaic modules, and the second contributor is the PVC. And the GVP has a negative value at this graph because of the carbon intake capability of glue-laminated timber. And other environmental impacts are calculated. And discussion at the discussion content, the literature studies are compared. The usage phase is the higher contributor in our study, and at
I think we are having a connection issue. Okay, so I think we are having a connection issue, and I believe that will be end for our session 4. So thank you for attending to our conference. This is the end of session 4, and we will see you in session 5.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi.